All right, we are on to our last type of conic section, which is a hyperbola. If you look at our double naped cone right here, a hyperbola is formed by taking a cross section that's perpendicular to the base, and you actually end up getting this piece right here, which looks like a parabola, but then you get a reflection of it also, right? So that's what a hyperbola looks like. Okay, so a hyperbola is a set of all points such that the difference of the distance from a point on the hyperbola to the foci are constant. A hyperbola has two separate parts called branches. So this is actually something where I wish you could actually see me to describe this, but I'll just use a drawing. An ellipse looks like this. Oh gosh, I know it's bad, but if you look at it, oh goodness, I tried really hard. Okay, so an ellipse, an ellipse looks like this. It makes me laugh because I tried really hard. Okay, this is a horizontal ellipse. It's like two sideways facing parabolas that are like touching, right? The hyperbola is if I took this and not moved it, but like I'm just going to move it forward. It's like if I flipped them inside out. So if I flipped one of them the other opposite direction, right? So if I flipped it going each way, this is what a horizontal hyperbola looks like. And then I can do the same thing for a vertical ellipse, okay? Or sorry, vertical hyperbola. I accidentally use the wrong words constantly. Okay, so there's two directions. There's horizontal and there's vertical hyperbolas. So let's start with the equation for the horizontal hyperbola. Really quickly, how we're going to graph it, the length of the transverse axis also. All right, so horizontal hyperbola, its equation looks exactly like a horizontal ellipse, but instead of a plus sign separating your two fractions, there's a subtraction sign. So it's x minus h squared over a squared minus y minus k squared over b squared equals 1. Okay, so let's do a quick sketch of this. The first thing you're going to do is you're going to graph your center. So let's say my center is right here, HK. Okay, that's my center. Then what you're going to do is you're going to find A. Okay, you're going to find A. A is whatever this number is, the square root of this. Okay, and you're going to count right and left since it's horizontal A units. So right A units, left A units. And I make those like giant. Okay, because those are my vertices. Then what you're going to do is you are going to graph two other points that aren't part of your hyperbola. They use them to create your hyperbola. They are B units from the center, and they'd be vertically, so they can be like up and down, let's say. And notice B can be bigger than A. B can be bigger than A. Okay? All right, so then what you're going to do is you're going to create a rectangle out of this. So you're going to need a vertical line, a horizontal line. You have to use dashes because it's a skeleton here. And then what you're going to do is you're going to draw an asymptote going through one corner, through the center, through the other corner. And then the same thing, one corner, through the center, through the other corner. And those are your two asymptotes. Then you're going to go back to your vertices. And if you're like, where are your vertices? I made them in blue right here, and they were supposed to be horizontal. So this is what my horizontal hyperbola looks like. The last thing you're going to do is you're going to find C using C squared equals A squared plus B squared. And you're going to get your foci. Your foci are going to be inside those two branches. Just like they're inside a parabola, they're going to be inside those two branches. And that would be C units from it. And that's what a horizontal hyperbola looks like. The length of the transverse axis is the question of us, how long is this right here? Let me put it in this. How long is this right here? Both vertices are a distance of A from the center, so it's just 2A. Okay, vertical hyperbola is not what you think, because people think, oh, my square is not there. Is not what you think. Some people are going to be like, oh, just switch A squared and B squared just like you did before. That's not what happens. You actually switch the numerators. So it's y minus k squared over A squared minus x minus h squared over b squared equals 1. So no matter what, the first thing is A. It's not the biggest one. The first thing's A squared, not the biggest one. The second one's B squared, no matter what. How can I tell if it's vertical or horizontal? By looking at the numerators. If it's xy, it's horizontal. If it's yx, it's vertical. Transverse axis is still 2a. So once again, the idea of what you're going to do here is you're going to get your center. Let's say it's right there, HK. You're then going to find your vertices. Your vertices are vertical from this, still A units. You're going to go up A units and down A units. That's the same distance. Well, that doesn't look like the same distance. So up A units and down A units, let's say. Okay? They have to be the same distance from the center. And I make those like big so my eyes are drawn to them. Then I'm going to find B, and I'm going to count right and left and go that much B. And I'm going to make this into a rectangle. Okay. You're going to make your asymptotes that go out the corners and through the center. They have to be dashed because they're not part of the hyperbola. They're just there to help you graph. Then you're going to go back to your vertices and you're going to graph your branches. Notice if you make those points ginormous, then your eyes are drawn to them. And then finally, your foci. Your foci are C units from your center, or C squared is equal to A squared plus B squared. So it'll always be past that point and somewhere inside your two branches. And that's what they're going to look like. Okay, so let's remind us of everything I just said. So A is the distance from the center to the vertices, and A is always first. A squared is always first. C is the distance from the center to the foci. And to find the foci, we're using C squared equals A squared plus B squared. So for an ellipse, we used a minus, and there was a minus here instead. For hyperbola, those are minuses, and there's a plus for this instead. Okay, so let's jump into graphing here. Given the equation, find the center, vertices, and foci, and graph it. So first off, I know it is a hyperbola because of the subtraction right here. So I want to decide if it's vertical or horizontal. Since it's x, then y, it's horizontal. Okay, people want to look at the denominators and say it's vertical because the second one's bigger, but no, it's not. It's horizontal. Next, my center, -2, 3. And I graph it, -2, 3. My vertices are next. My vertices are A units from my center, where A squared is 9. This is A squared. This is B squared. Okay? So A is plus or minus 3. Now, since this is horizontal, I'm going right 3 and left 3. Right 3, 1, 2, 3, left 3. And I make those, like, annoyingly large. Okay, so that's 1, 3. And -5, 3. All right, now I need the other 2 points. They're not called co-vertices, but if you called them co-vertices, I know what I'm talking about, but they're not part of the hyperbola at all. They're used to make the skeleton. All right, B squared 16, so B is positive and -4. So I'm going to go up 4, 1, 2, 3, 4, and make a point, and down 1, 2, 3, 4, and make a point. And notice I'm not making those crazy like the blue ones. Okay, so I need to make this into a rectangle. So from this point, I'm going to come down. I'm going to come over. Come down from that. Go up from that. And there's also a dashed line maker in Notability, but I'm not that crazy. Okay, so now you're going to make your asymptotes. You're going to go through the corners. All the way across all of your graph paper here so that you can have the most accurate graph possible. And through the corners here. All right, and now I'm going to make my 2 hyperbolic branches. So I'm going to go back to my vertices. If you see them, they should be jumping out at you. If not, this is horizontal. But notice that I'm getting closer and closer to the asymptote. Closer and closer to the asymptote. Please don't go like this. That's not how it looks. The asymptotes are there as a guide. You're going to follow them. And there's your 2 branches. All right, last but not least, notice I don't have you list co-vertices because there aren't any. Last thing you're going to find is your foci. Your foci are C units from your center, where C squared is equal to A squared. If you forget which one, look here. Not that. It's plus B squared. C squared is equal to 9 plus 16. C squared is 25, so C is positive and -5. don't have to estimate that. I know how far 5 is. So this is horizontal, so I'm going to go back to my center, right? I'm going to go right 5. That's a focus. And I'm going to go back to my center. I'm going to go left 5. Don't go from your vertices. You're going from your center. Now you're going to list those 2 points. They're not floating. I can tell where they are. One is at 3, 3, and the other one is at negative 7, 3. And that's it for a hyperbola. So as you can see, there's 3 more practice ones. Let's go ahead and do those just to make sure everyone feels comfortable. I know it's a hyperbola because there's a minus separating it. It's y then x, so now I know it's also vertical. I'm going to get the center, which is HK, so that's negative 4, 1. So make sure you don't put 1, negative 4. If you go back up here, remember this is H, this is K. H goes with X, K goes with Y. Okay, so sorry, negative 4, 1. I'm going to graph that. Negative 4, 1, right there. All right, now I'm going to get my vertices. My vertices are A units from my center. Oops, B squared. So A squared is 25, so A is plus or minus 5. Since this is vertical, I'm going to go up 5. 1, 2, 3, 4, 5. Down 5. 1, 2, 3, 4, 5. And those are my vertices. I'm going to write them down. Negative 4, 6. And negative 4, negative 4. Okay. Now I'm going to get B, and I'm going to use that to help me graph. So B squared is 4. B is plus or minus 2. So I'm going to go right 2, left 2. Notice I don't make a big deal about those. And then I'm going to create a rectangle out of this. I'm going to draw my asymptotes going through the corners. All right, go back to your vertices and graph your 2 branches. My vertices are these purple dots right there, points. So it's not hard for me to tell what they are. But it is vertical, so I know it's not the other 2. All right, last but not least, I need to get C. C squared is equal to A squared plus B squared. If you forget, remember, look up there, it's a minus, don't do that. C squared is equal to 25 plus 4. So C squared is root 29. Sorry, it's 29. And then square root plus or minus, and I get C is positive or negative root 29. Which can't be simplified, so I'm going to leave it, but I can't estimate it. It's a little bit more than 5, so it's 5 point something. So since this is vertical, I'm going to go from the center. I'm going to go up 5 and a little bit more, and down 5 and a little bit more. Now, if you look at those points, they are floating. So since they are floating, I'm going to use my center for help. I went up and down, so the y value is going to change. The x value is not. Negative 4, comma. From my y value of 1, I went up and down root 29. All right, next one. I need the orientation. It's subtraction, so I know it's a hyperbola. Y then x, so it's vertical again. My center is 0, 3. Over 0, up 3. All right, now I need to find my vertices. This is A squared, this is B squared. A squared is 9, so A is positive and negative 3. Since I'm going vertical, I'm going to go up 3, 1, 2, 3, and down 3, 1, 2, 3, and those are my vertices. My vertices are at 0, 0, and 0, 6. All right, now I'm going to find B and make my rectangle. B squared is equal to 36. B is positive and negative 6. So I'm going to go right 6 and left 6. Make that into a rectangle. And then go ahead and draw on your asymptotes. Through the center and out the corners. Notice I can't make a straight line to save my life, so I start at the center and go out a corner and then go back. Ugh, it's awful. Okay. Go back to your vertices. They're in blue there. And make your vertical hyperbola. This is a very wide hyperbola. All right, now I need my foci. My foci are c units from my center, where c squared is equal to a squared plus b squared. So c squared is equal to 9 plus 36. C squared is equal to 45. Square root plus or minus. Square root plus or minus. So I have c is equal to plus or minus. 9 goes in there 5 times, so 3 root 5. I need a decimal approximation of this. This is a little bit less than 49, root 49, which is 7. So this is 6 point something. All right, go back to the center. All right, you're going to go up 6, 3, 6, and a little bit more. And down 6, 3, 6, and a little bit more. Okay, so when looking at it, I counted wrong. I can tell because it doesn't look balanced. Up 1, 2, 3, 4, 5, 6, and a little bit more. There we go. 1, 2, 3, 4, 5, 6. You know what I did? I counted from the vertex. Make sure you're going back to the center. Okay. There are my foci. If you want to check yours to make sure they're right, one should be in between, it's at 0, comma. One should be in between 9 and 10, and the other one's in between -3 and -4. All right, but once again, they're in between. So I'm going to use my center for help. So I did not move left or right, so that's 0. But from 3, I moved up and down 3 root 5. All right, one more left, and if you look, it's not in its standard form. I do know that it's a hyperbola because there's an x squared and a y squared, and I see that there's subtraction separating them. But in a hyperbola, it's equal to 1. So I want to start by dividing all 3 terms by 225. All right, now I can simplify each of these fractions. 9 goes into itself once. It goes into 225 25 times. 25 goes into itself once, and it goes into 225 9 times. And then this is 1. So standard form is x squared over 25 minus y squared over 9 is equal to 1. Since it's x, then y, this is horizontal. The center is 0, 0. Go ahead and graph your center. All right, now I need to find a. A squared is 25, b squared is 9. So a squared is equal to 25. A is equal to plus or minus 5. So since this is horizontal, I'm going right 5 and left 5. I'm making these vertices jump out at me. I made them green this time, so I gotta be careful. All right, now I'm going to write down the location of them. They are at -5, 0 and 5, 0. Or you can write plus or minus 5, 0. Now I'm going to get b. B squared is 9, so b is plus or minus 3. So from my center, I'm going to go up 3, down 3. Make this into a rectangle. And draw my asymptotes. Go out the corners and through the center. Out the corners and through the center. Okay. I can make my 2 hyperbolic branches by going back to my vertices, which are on, that I'm going to have 2 horizontal branches. Make sure you're putting arrows to show that they go on forever. And then the very last thing I need to find is c. C squared is equal to a squared plus b squared for a hyperbola. C squared is equal to 25 plus 9. C squared is equal to 34. Square root plus or minus. Square root plus or minus. Root 34 is not simplifiable. I am going to approximate it. It's a little bit less than root 36, so it's 5 point something. So I'm going to go back to my center. It's horizontal, so I'm going to go right 5 and a little bit more. Go back to my center. Go left 5 and a little bit more. And that's where your foci are. Once again, they're floating in between 2 values, so I can't estimate. I'm going to use my center for help. So from my x value of 0, I went left and right, root 34. I did not move up or down. Now you can also realize that you don't need the 0 right here because 0 plus root 34 and 0 minus root 34 or root 34 and negative root 34. But if you put the 0 plus, I'm